So let's look at your warm-up for quiz 2. It starts off saying the most abundant isotopes of oxygen are oxygen 16, oxygen 17, and oxygen 18. Which of these three isotopes is the most abundant or the most common in nature, and why? You have to remember that the one that is the most abundant will be the one that the average on the periodic table is going to be closest to. And that is because that average on the periodic table is a weighted average. So it gets weighted down by the isotope that comes up the most often. So if we look at the periodic table, the mass of oxygen is 16.00, which means that if you add up all the oxygen 16s, all the oxygen 17s, and all the oxygen 18s, and then divide by the total number of all of those, the average coming out closest to 16 means that there must be way more 16s than 17s and 18s. So, which of these three isotopes is the most abundant in nature? That's got to be oxygen 16, which we know because the average atomic mass on the periodic table is 16.00, which is closer, obviously, to 16 than 17 or 18. For this next one, we have to fill in the chart. When you're looking for your isotope to go in, that's just this K39, K40, K41. Those are the labels of our isotopes. Each one of those isotopes comes with a percent. So again, you can just copy those straight out of the problem. To change a percent to a decimal, you can divide by 100. Ultimately, that ends up being the same as moving the decimal point twice to the left to make it smaller. And when you do that for these single digit or ones place percents, make sure you stick a leading 0 in front. The mass you're going to use is actually going to be from the isotope name. This 39, 40, and 41, those are the masses of each of the isotopes. Then when it says product, it's trying to remind you to multiply. You're going to multiply percent times mass for each of these to get a product that you can write into this column. So you're just multiplying across in your calculator, and then you just add all of these together, and it even is reminding you to add them, so that your total 39.13 is your final answer. Number 3 says that rubidium has two isotopes, rubidium-85 with a 72% abundance and rubidium-87 with a 28% abundance. Which one will the average atomic mass be closest to? And then it says no calculation is needed for this problem. You do not have to do any math to answer this. And in fact, when we're telling you no calculation is needed, we actually are preferring that you do this without doing any math. You should be able to reason and logic your way through this. The average atomic mass, remember, is a weighted average, so it's going to be closest to whatever one is the most common. Most common could also mean most abundant. So if you look at the one with the highest percent abundance, that tells you that that isotope that is the most abundant will be weighing the average atomic mass toward its mass the most. So rubidium-85 is the isotope that the average atomic mass will be closest to, which we know because it has the highest abundance. Then the following table lists relative abundances of a particular element on the periodic table with the mass of each isotope. Which element most likely has this isotopic composition, and how do you know? First, you need to look at the chart. We have 3 masses. Each mass has a percent abundance. You need to decide what is the most important thing in this chart. And hopefully you land on the most important thing being the percent abundance. The highest percent abundance in particular. Because the one that is the highest percent, whatever mass it is, will weigh the average the most toward it. So knowing that the highest percent abundance goes with a mass of 19.992, we need to look on the periodic table for an element with the mass closest to 19.992. And if we check, fluorine is 19.00, neon is 20.18. That is closest to 19.992. So what element is this most likely? The element is most likely neon, which we know because its mass, 20.18, is closest to the mass with the highest abundance. That mass being 19.992, which is 90.48% abundant.